Hello, hello, Algebra 2. We are on to Quad 4, which is solving quadratics by completing the square. What is completing the square, you ask? That's a great question. That's our target today. But you're also going to see a little bit of this something we've done already before. So with that said, let's go ahead and get started. What we've got is we got solving quadratics in the form ax squared plus bx plus c equals 0. Sometimes we can do that easily solving by factoring, right? We've already talked about that. We've done factoring. And for example, that first one, if we've got x squared plus 6x minus 16 equals 0, we could easily get to factored form being x plus 8 times x minus 2, and then finding our solutions of -8 and -2. Okay. Sometimes you can get in a quadratic equation that cannot be factored using integers. Okay, we can't factor it like we normally would. We got two options at that point. Okay, we've got two options. Essentially, it's when we have something times x, we have two options. Option one, completing the square, which is what we're going to talk about today. Option two is quadratic formula, which is our next target. So let's go ahead and take a look at this thing. Quadratic formula we're generally going to use when that a, or the number multiplying, the coefficient multiplying x squared, is greater than 1. So today we're going to do what's called completing the square. Completing the square. We're going to make ourselves a perfect square. We're going to get a perfect square equals a number. And how are we going to do that? By some fun math. Math is always fun though, right? Solve x squared plus 8x minus 10 equals 0 by completing the square. Now we know that we don't have anything that multiplies to -10 and adds to +8. But what we can do is called completing the square. So since I have this, what I will do first, because right now I'm starting with ax squared plus bx plus c equals 0. Since I cannot factor, what I'm going to do is take my term that doesn't have any variables, right? Take the term that doesn't have any variables, my constant, if you will. In this case, it's -10. And I'm going to add that to both sides. Well, in this case, get rid of it on the left. I'm going to add 10 to both sides of the equal sign to get x squared plus 8x equals 10. Now you're saying, Mr. Brayman, this isn't going to work, right? Well, I mean, I could take your greatest common factor out of these two things, but that doesn't work because it's not the zero product property. Well, you're right. Just hang on though, okay? What we're going to do is we're going to turn this into a perfect square. What we're going to do is take that b value, that number, that constant that's multiplying x, and divide it by 2. We're going to get that as 4. And then we're going to take that value and square it. So we're going to have two things. We're going to have b divided by 2, and we're also going to have b divided by 2 squared. In this case, b divided by 2 is 4, and that 4 squared gives us 16. What we're going to do is something that makes sense once we think about it. We can add something to both sides as long as it's the same number. And that's what we're going to do. What we're going to do in here, we're going to take and add 16 to both sides of the equal sign. And we just did that, right? We divided that out. We divided that out, divided the b value by 2, squared it, added it to both sides. Now we have x squared plus 8x plus 16 equals 26, because 10 plus 16 is 26. This is a perfect square. What do I mean by perfect square? Trinomial, because that's what we got. Trinomial, tri is 3, right? Trinomial. In other words, this becomes what multiplies to 16 and adds to 8. Well, 4 and 4. It's a perfect square. It'd be, if I was to factor it, it would be x plus 4 times x plus 4. Well, the same thing multiplied by itself is x plus 4 squared, right? It's something squared. X plus 4 squared equals 26. Now, we've done that. We've solved from there before. That's quad 1. We've solved from there before. We've got a perfect square equals a number. We just got to take the square root of both sides and simplify. In other words, take the square root of both sides. X plus 4 equals plus or minus the square root of 26, and solve for x by subtracting 4. That's a lot. That's a lot. That's okay. Let's go ahead and take a look at this in another example. Okay, let's go to the next page here. We're going to solve each quadratic by completing the square. In other words, what I'm going to do is I'm going to get my squared term and my term that just has just a plain variable on one side, and then the number, the constant on the other side. I'm going to make this, I'm going to turn this into x squared, or a squared, sorry, a squared plus 2a equals 3. A squared plus 2a equals 3. I like to do this way. I like to kind of combine some steps in here. Let me show you how I do this. I am going to leave myself some room to add something to both sides of the equal sign. And the number that I add to both sides of the equal sign, I'm going to set this up as one. I'm going to set this up as one step here in this bracket, okay? I'm going to take and divide my coefficient by 1, just like we talked about. That b value divided by 2, 2 divided by 2 is 1. And I'm going to square that number and add it to both sides. This would become a plus 1 squared equals 4. And again, if we factored this, right, if I added 1 to both sides, what multiplies to 1 but adds to 2? 1 and 1. Or a plus 1 squared equals 4. Now I know this one, yeah, we could have factored it, but that's okay. That's okay. From here, I can take the square root of both sides. A plus 1 equals plus or minus the square root of 2. I'm sorry, square root of 4. Square root of 4, which is 2. And I subtract 1 from both sides. This gives me negative 1 plus or minus 2. And I can do this, so I should. Negative 1 plus 2 is 1. Negative 1 minus 2 is negative 3. Those are my solutions. Okay. Let's see this again. We're gonna do this again. Okay. We're gonna do this again. And sometimes we might get some imaginary solutions, and that's okay. And that's okay. Watch this again. Okay. I'm going to subtract 8 from both sides. A squared minus 2a. I'm going to leave some room to add something to both sides. And how do I know I'm adding something to both sides? That's a great question. How do I know I'm adding something to both sides? Because when I take the square of a positive or negative number, I'm going to get a positive number. If I square a number, I'm going to get something positive. Again, take this, make this a one-step deal here. I take this value and divide it by 2. I get a minus 1 squared. I take and square. What is negative 1 times negative 1? Because that's negative 1 squared. Yes, that is positive 1. So I end up on the left-hand side, a squared minus 2a plus 1. And I say, self, what multiplies to positive 1 but adds to negative 2? And yeah, that's negative 1 and negative 1. Or a minus 1 times a minus 1, which is a minus 1 squared. So what I'm trying to do is kind of compress all that stuff and give you that right to begin with. A minus 1 squared equals negative 8 plus 1, which is negative 7. And then from here, we've already done this part before, right? Now we just take the square root of both sides. We have a minus 1 squared. I'm sorry, a minus 1, we take the square root, is plus or minus the square root of negative 7. Well, we know this that whole negative business. We have a negative in the square root. We pull the negative out, call it an I. See if we can simplify. We can't simplify square root of 7, though. What we end up with here, we end up with a equals 1 plus or minus this I times the square root of 7. Okay. It's just that first part that's new. Okay. Let me do one more with you. Let me do one more. Okay. I'm going to take and move the 26. I'm going to subtract 26 from both sides. I'm doing number 7. Okay. I have m squared minus 12m. Leave room to add something to both sides equals negative 26 plus some number. And now I'm going to set up my perfect square. This ends up being m something squared equals a number. I take that, whatever number's multiplying my plane variable, in this case it's a plane m, my coefficient of m. My coefficient of m is -12. I divide that by 2, I get -6. Put that right in there. That becomes m minus 6 squared. I take -6 and I square that value. I'm going to be adding 36 to both sides. And now what I end up with is m minus 6 squared equals a positive 10. Once again, m squared minus 12m plus 36. What multiplies to positive 36 and adds to -12? This would end up being m minus 6 times m minus 6. And if it's the same thing multiplied together, by itself, something multiplying itself, that's something that's squared. In this case, m minus 6 times m minus 6 can be represented as m minus 6 squared. And from here, we've already got this knowledge. We take the square root of both sides. M minus 6 equals plus or minus, don't forget, the square root of 10. We cannot simplify the square root of 10 any further. We add 6 to both sides, and m equals 6 plus or minus the square root of 10. Okay, so what you're going to do, I'll do the rest of these for you to check, right? And we're going to work through these things. Go ahead, try some out, see what you get, ask some questions you don't understand. Take care. Have a great day.